Welcome to Hot Topics. In this video, we're going to discuss the difference between Table 430.52 and Section 430.52C1, exceptions 1 and 2. Now, to start with, we have to find three currents. That's basically the general rule. Now, to do this, let's just go over to page 308 and 309 of your code book. And on the right-hand side of the page, 308, down at the very bottom, right-hand side, we pick up 430.6A. And then on page 309, left-hand side of the page, right below the table, you'll pick up the table values. And to find the full load current of the motor, we would go naturally to table 430.250 around page 333 of the code. But now the first current we would find is in the illustration that you see. Its nameplate is 62 amps of this 50 horse, 460 volt, three-phase motor. That's current 1. Now current 2, we would find the table current, so we would have to naturally go over to about page 333, and of course you're very familiar with this table, you motor folks. And you notice the first column to the left of the table is titled horsepower. We'll just scroll on down there till we get to 50 horsepower, and just slide across there horizontally there and pick up 460 volt three-phase, and it's 65 amp. And then the third current that we find now, we have to go back and I believe that's around page 310. So let's go back to page 310 with me if you have your code book handy. Page 310. And we would get the starting current either by the locked rotor number that's on the code. And of course that's a code letter. And of course we know if it's code letters A through G, we can figure about 6 times the full load current rating of the motor, and that's a good rule of thumb. But that table is 430.7B as in boy. And most of the motors we install, I'd say 95% of them are code letter B. And you can see it can start at a minimum of 315 up to approximately 3.54, it looks like. So that's how we would find it, the starting current of the motor based upon the locked rotor code letter. And then if we didn't want to do that, we could drop down to 430.7A9 on the left-hand page of 310, left-hand side of the page, approximately about the middle of that column. And notice we pick up the design lever, B, C, or D, and that's how the motor is manufactured. Now to accomplish that, we have to go back over to about page 334, if you'll just head in that direction with me, and we'll go over to page 334. Bear with me here a minute. The eyes ain't what they used to be. But on page 334 now, we get the starting current on the letter based upon the design letter, how the motor's manufactured, B, C, or D type of design. Again, on the left-hand side of the page, the first column, we pick up the horsepower in the table, scroll on down to 50 horse, slide across there to your 460 volt, and that motor would start at approximately 363. So we kind of pick up the three currents. We had nameplate 62 amps from the motor. We would pick up the full load current rating to size everything now except the overloads, which would be the nameplate on the motor. We'd use that value. So we'd pick up 65 amps from table 430.250. Third current was the starting current, 363, from table 430.251. Now, with those values found, we could look at the illustration, and we have a circuit breaker in the panel board, and we're just going to focus on that circuit breaker and size it to start that motor. So the first step that we want to take, well, we'd want to go to table 430.52, so let's go to about page 319. You'll just boogie over there with me to page 319. Four things now good designers would have to know to design properly by the code. First of all, what are the phases of the motor? Well, it's a polyphase three-phase. So look at the type of the motor, column 1, table 430.52, there on page 319, it looks like. Now, if we get the design of the motor, it was B, so you'll slide on down, and slide right across for a code letter B, other than code letter B, 250% now. Now keep in mind that this 250% from the table is your starting point. You can always round down. In some cases, if the motor won't start and run, you could round up. But let's just look at that process. But first of all, let's apply the 250%. So the next illustration that we're looking at, notice step 1, we have went to 430.6A1 and table 430.250. The 50 horse is 65 amps based upon 460 volt three-phase. Number 2 now, we're going to select from table 430.52, 250%, which we've done, and step 3 is the application of the 250% times 65 amp. We come up with 162.5. Now this is in step 3. Now this is where we have to decide what we want to do with this 162.5. So now we have to just look at page 318, and you might want to mark this if you're not used to applying this section. But 430.52C1, I'm not going to read the whole thing and bore you to death, so I'm going to paraphrase it. It says you cannot exceed the 250% step 3. So you're going to round down. So you could say then C1, in accordance with table 430.52, is the round down size, if you wanted to write that in. And if the motor wouldn't start and run, or you just wanted to go ahead and round it up, and usually we round up as electricians based upon how long it would take the motor to accelerate the load, is a basic rule. But you can round up automatically. When you read the exception 1 and what it says you can just round up if you want to. So I could either then round up, as in step 4, to 175, round up above 162.5, or in step 5, the minimum size, I could round down to 150. But that's, using table values. And you can always round down as low as you want it to go, as long as you can start your motor and accelerate your load. Keep that in mind. See, people get confused with that. And we've select these size overcurrent protection devices from table 240.6A. So now, reviewing this now, we can either round down or round up in accordance with 430.52C1, exception 1. So that's what we've applied, either C1 or the exception 1, round up or round down. Now say due to the acceleration time of your motor and load, we had nuisance tripping of your protective device. So you may want to apply the exception 2, and the first thing you do is review step 1 in the illustration. 65 amps is 100 amps or less, so you can go up 400% and have increments of steps if that worked out for you. And if it was above 100 amps, then you could use 300% times 65 by the exception 2 to 430.52C1 here on page 318. Now, let's just look at that at the next illustration. And notice when we review the next illustration, step 1's the same. It's a 50 horse, 65 amp. 430.52C1 exception 2A in the 2017 code, but that's 2.1, exception 2.1 in the 2020, and table 430.52 remains the same, and that exception 2.1 would let you go up to 400%. So the application in step 3, 400% of 65 is 260. But now notice there's no exception to let you round up. You must round down because the exception 2.1 says you can't exceed it. So we would round down to 250, 240.6A. But now notice your conductors are sized by 430.22, and they're sized at 125% of 65, which were required by the number 4 conductor. You wouldn't want to raise the conductors to match the overcurrent device rating because you couldn't terminate. You couldn't get them under the cover or electrician torque, the peggerhead of the motor. Now, you have it. That's basically the difference in the application of table 430.52 and section 430.52 C1 exceptions 1 or 2. My name is James Stallcup, and thank you very much for watching this video. And if you want to learn more and more about motors, just go to chapter 18 in Stallcup's Designing Electrical System book, volume 2, or just go online and look at our videos in chapter 18, and you can start from scratch and just go right through the whole article, I shouldn't say article, but chapter 18, and learn a lot more about motor design and installation. Have a good day.